Hello, this is my science MYP. It's a PowerPoint by Simon Van Ham. In this PowerPoint, I will be talking about nuclear energy, in particular nuclear fission. What is nuclear energy? It all started when the Nazis dropped a nuclear bomb. After this horrific experience, nuclear power was promised to be a new way to save technology. It was the first way to create a massive amount of energy in a short period of time. Nuclear energy is energy in the nucleus core of an atom. In order for this energy to become the energy we need, the energy must be released. It can be released from atoms in two ways: nuclear fission and nuclear fusion. In this PowerPoint, I will be talking about nuclear fission. Nuclear fission is the splitting of the nucleus of an atom into two smaller nuclei. This type of reaction releases a great deal of energy from a very small amount. For example, nuclear fission on a tiny piece of uranium can release as much energy as burning 1,000 kilograms of coal. The reaction begins when a nucleus of uranium absorbs a neutron. This can happen naturally or when a neutron is forcefully crashed into a uranium nucleus in a nuclear power plant. In either case, the nucleus of uranium becomes very unstable and splits in two. This energy now has a lot of potential energy which can be turned into kinetic energy. So as you can see here on the first diagram, you see the neutron, and then here you see all the nucleus inside it. And then when the splitting of the atom is happening, when it splits, the release of energy is created, which like little neutrons shoot out kind of. And then the fission product is created, which is the energy we use. In the reactor core, which is in the second diagram, this part here, the uranium is organized in different groups. Uranium pieces of the same length are arranged in rods, and these rods are put into groups. The uranium bundles are placed in a container and then put in the water that works as a cooling method. The heat of the uranium bundles in the reactor core must be controlled to prevent overheating, which could cause the reactor to melt, which are the causes of big accidents like the nuclear power plant in Japan. Rods in the uranium group are sometimes brought lower to the water to prevent overheating and meltdowns. The rods can also be lowered all the way down to stop creating heat and to shut down the reactor in case of an emergency or to change the fuel. The next step in producing the energy we need is by making the water really hot, which is done by the nuclear reaction. Then the steam that comes from the hot water goes through a tube into a turbine. This steam then powers the turbine, and the turbine creates energy, which is then transferred to our houses. This is how electrical energy is made and how the potential energy I talked about earlier is turned into kinetic energy. So, as you can see in the second diagram, here you have the reactor core. So you got the water to cool it down and the heat to pressure all the atoms to split, which is done in the pressurizer up here. Now, the heat makes the water turn into steam, and the energy from the nuclear fission goes with the steam into this turbine, and that powers the turbine, which powers the generator, and it transfers the energy through to our homes and offices and whatever else it's used for. In my opinion, nuclear energy is really, really good. Some people may think that it is very dangerous, but I think of it this way. When you hop in a car every day, the chance of you getting hit in a car is so much higher than a nuclear power plant having a meltdown. Now, of course, if a meltdown does happen, it has a way bigger effect on us people, but I still think nuclear power plants are good just because they don't pollute the air and can help a lot. Positives about nuclear energy. The first one is, nuclear power plants are pretty much eco-friendly as there is no polluting air that is sprayed out. It's just steam, which is no harm to anything. It is literally boiled up water. Secondly, the materials that are used in nuclear power plants, like uranium, gives out way more energy than any other energy source for the quantity needed. In fact, one power plant can give electrical energy to 60 million houses for a whole year. And then lastly, running a nuclear power plant is very cheap. The power plant itself may be expensive, but the uranium and the electricity of the power plant produces are really cheap. Negatives. Firstly, if a meltdown does ever happen in a nuclear power plant and is unnoticed, this could lead to a massive disaster, as the nuclear power plants will explode and lots of nuclear radiation will be let out in the air, which could kill us. Secondly, nuclear energy is not a renewable energy source. When it's been used, it cannot be used again. And then lastly, the main source of energy, uranium, is very hard to find and mine. The mining method is not a clean process. So for nuclear fission to be created, we need uranium, which is not a clean way to get. Should nuclear energy be used all over the world? In my opinion, I reckon nuclear energy should be an energy source for big buildings or areas only, just because nuclear energy is really good at producing a lot of power in a short period of time. For example, nuclear power plants should be built for places like industry places and other big places that need a lot of energy. The reason I think nuclear power plants should not be used around the whole world extensively is because when more power plants are built, more meltdowns will be created and more big accidents like the nuclear meltdown in Japan will be happening. Also, people will be closer to the meltdowns as there will be more power plants, and this could cause a lot of deaths. This is my bibliography, so I'll just wait here for a bit so you can look through it a bit easier. And then the second page. And that is my PowerPoint. Thank you for listening.